Hi, this is Dr. S, and this is my final video on my series on aromatic chemistry for OCR A-Level. This is about how we use directing groups to produce a particular product, which is a really important skill in synthetic chemistry. So just to remind us, we've looked in the last couple of videos at activating and deactivating groups, which then become 2,4 directing if they're activating, and 3 directing if they're deactivating. And remember, the ones that we need to know of are the OH, the NH2 for 2,4 directing, and NO2 for 3 directing. So how we'd use this is we might be asked, how do we make this compound? And we would have to work out which substituent was added first. So we'd need to know what director each of them are. Now we know that the nitro group is a 3 director. So if the nitro group was on first, the next thing to be added would have gone on to the 3 position relative to the nitro. So that would be here or here. You can see that the chlorine group is not in either of those positions. So the nitro group cannot therefore have been added first. Although chlorine is a group that we don't need to know which director it is actually 2,4 directing. An exam question would tell you that. So if the chlorine was added first, the next thing to be added, the nitro, would go on to the 2 or the 4 position. So that's there, there, or there. And you can see that the nitro group is in the 2 position. So that backs up the idea that the chlorine was added first. So your full synthetic scheme would be from your benzene plus some chlorine with the aid of a halogen carrier to produce chlorobenzene. And then the chlorobenzene plus nitric acid with a sulfuric acid catalyst to produce 2-nitrochlorobenzene. There would also be, I have to say, a second product here, which would be 4-nitrochlorobenzene, because it's a 2,4 director, so you would get both products, and you'd have to separate them somehow after that. Let's look at one more example. How about making this? Now, if you feel confident with this now, feel free to pause the video, have a look at this structure and see if you can come up with the synthetic scheme. Okay, so again, we're thinking about what is the directing group here that is added first. We know that the nitro group is a 3 director, so that's to this position or this position. We now know that halogens, this bromine, is a 2,4 director, so that's to this position, or this position. In this case, the nitro was added first before the bromine. So again, our full synthetic scheme would this time be a little bit reversed, in that we'd add the nitric acid with the sulfuric acid catalyst first to make nitrobenzene, and then to that we'd then add bromine with a halogen carrier to make 3-bromonitrobenzene. I have omitted side products at each stage. Okay, so you can see how we've decided which group is added first by looking at the directing potential of each one. So I'm going to put a couple of examples on the screen for you to have a go at and to decide which order they were produced in. Okay, so the first one I'd like you to look at is that how would I create that from benzene? And the second one, how would I create that from benzene? So have a look, pause the video, try and work out the synthetic schemes. Okay, so what we should have found is that this one here, they are at the 3 position relative to each other. Now methyl groups are 2,4 directing. Again, it's not one that you need to know. We have seen it in previous videos and they would tell you in an exam. But the critical one we knew was the NO2, which is a 3 director. So this goes on first, and then the methyl group second. Whereas here, the methyl group goes on first, and then the nitro group second. So I'll go through the scheme for this one. Benzene plus nitric acid in the presence of sulfuric acid to make nitrobenzene. And again, note that I put the nitro group at an angle here. I didn't put it at the top. That's a really common thing that the exam board will do to try and trip people up. It doesn't matter if it's at the top or not, as long as they're correct relative to each other. Then from you would then add that chloromethane in the presence of a halogen carrier, and that would go on the 3 position. So here it would go there. For the second one, the 2 steps would be reversed. So you do this step first and then this step. Okay. They will only ask you about putting 2 groups on. So as long as you can think about the 3 directing groups you need to know of, the OH, the NH2 and the NO2, and decide which order you need to put them in, then you'll be fine. The added complication is you don't need to know how to put an OH group onto a benzene ring in the A level, so they're probably unlikely to use phenol in one of these types of questions, but they might use phenol in one of these types of questions. So what they may ask is something like this. If we had this compound, whereabouts would the next substitution be likely to be? Okay, so just pause the video, have a look, try and think, where would the next substitution be? Okay, so now we have 2 groups on our benzene. So we have to take into account the directing potential of each one of the groups. But here we have 2 OH groups. They are both 2,4 directing. So relative to this phenol, this is position 2, or that is position 2. Position 4 is taken. Relative to this phenol group, this is position 2. This is position 2 or 6. And position 4 is taken. So actually all 4 positions are going to be equally likely to react with this. So if we're putting an asterisk on the ones that are most likely to react, it would actually be all 4. So I'm going to put a few more on screen for you to have a go at. So again, what I'm going to ask you to say is whereabouts would the next substitution happen? Where is the most likely position for the next substitution? So there are going to be 3 examples. Okay, if you pause the video and try and work out where would the next substitution be and put an asterisk next to the correct position. Okay, in this example, OH is a 2,4 director, so that's position or that position. This 2 position is taken. The nitro group is a 3 director, so that's to this position or this position. So you can see that these 2 positions are going to be the favourable places for the substitution. So it's going to be there and there. There's almost no chance of there being any substitution there or there. On this one here with the 3 methyl groups, okay, the methyl groups are 2,4 directors. So have a look at where the positions 2 and 4 are. So from this methyl group here, this is a position 2, that's a position 2 or 6. This is a position 4. From this methyl group, position 2, position 2, position 4. From this methyl group, position 2, position 2, position 4. All 3 positions that are available are equally likely to react. So we can asterisk all 3. And in this final one, we have 3 nitro groups. Nitro groups are 3 directing. So this nitro group would direct to this position, which is already taken, and this position that's already taken. This nitro group would direct to this position that's already taken, and this one. And this nitro group would direct to this position and this position. So they are all directing to positions that are already substituted. So there is no position that would be suitable for further substitution with this. So there would be no further substitution. Okay. I hope you've enjoyed my series on aromatic chemistry, and I hope it helps clarify all your understanding. Okay, I'll see you for my next series soon. See you then.